Hello, this is our final unit in the class, and it is on files. Storage of data in memory is temporary. Files are used for data persistence, permanent retention of data. Computers typically store files on secondary storage devices such as hard disks, CDs, DVDs, etc. C++ views each file as a sequence of bytes referred to as a stream. Data flows in from the stream and out to the stream just like in the real world, like water does. Each file ends with an end-of-file marker. When a file is open, an object is created and a stream is associated with the object. The streams CIN, COUT, CERROR, and CLOG are created when IO's stream is included. There are special cases of streams. The streams associated with these objects provide communication channels between a program and a particular device. CIN, for example, accepts input from the keyboard or other devices. COUT is used to output the data to the screen or other devices. CERROR and CLOG are objects used to output error message to screen and other devices. So the headers you're going to need are IOStream and FStream. FStream is where the stream for classes are included. Basic_IFStream is a subclass of basic iStream, and it's for file input. Similarly, OFStream is a class for file output. FStream is a subclass of IOStream that does both input and output. Each has a predefined specialization for character I/O. In addition, the FStream library provides typedef aliases for those template specializations. IFStream is an alias for basic_IFStream character. OFStream is an alias for basic OFStream character. FStream is an alias, etc. Again, C++ imposes no structure on files. You do that yourself. Strings have no concept of records. You structure files to meet the application's requirements. So now we're going to look at a file writing demo. So here I've written a small method to write a basic address structure to a file. So we pass in the file name and an address object, which has name, address, phone number, etc. And what we do here is we create the output stream, giving it the file name, and we say that it's for output by using the iOS out constant. And then we see if we can create the file. If we can't, we might want to throw an exception. So what we will do, this writes a single address, by the way. What we will do here is just say outstream, just like we use cout, and print everything to it, and then we close the stream and return true. Boom. That's about as straightforward as it gets, and that's how you write to a file. If I want to write multiple addresses, I can use a loop. So that's literally about as straightforward as it gets. So now in that last demo, we open the file for output by creating an OFStream object. Two arguments are passed, the file name and the file open mode. For an OFStream object, the open file open mode can be either out, append, which appends to the end of the file, doesn't overwrite it. Otherwise, when we open a file, if we don't provide a path, its location, it shows up in the local directory, same directory as the program. And the OFStream constructor opens a file, kind of establishing a line of communication. So our last demo wrote data to a file. So the file open modes are APE, ATE, open a file for output and move to the end of the file. This is append data for a file. We can open a file for input. We can just open a file for straight output. We can discard the file's content before we use it. And then open a file for binary input or output, non-text. So you can create an OFStream object without opening a specific file, and then open it later using explicit open command. So here we say we create the object, and we see how file got open and give it the same information. And we close a file when we're done with it by explicitly saying close. Usually the destructor will explicitly close the object, but always better always explicitly calling close is safer. So to read data from a file, instead of using OFStream, we use IFStream, and it can receive the file name and file open mode as arguments. Just with an OFStream object, an object can be created without opening a specific file because it can be attached later. And before attempting to retrieve data, use the condition !in to determine whether the file was opened successfully. And we'll go back and we'll take a look at our file reading data. Here we're going to read multiple records from the file by opening the file for an in-stream file for in. And we're going to create a vector to store the addresses we read in. And then we're going to say, if we can't create the file, throw an error. Now, while we can get more data, in other words, while in stream, create a new address, use getLine to get a string for each of the various types. And once we've created our address, we use pushback to add it onto the vector. And then we return our list of addresses that we've read in. Pretty straightforward. So with that, we come to the end of our journey and an introduction to C++. And thank you very much, and it's been great working with you.